Okay, so can you see the slide here?
Yes.
Yes.
Okay, so these are the three important thing you should know: pH, PCO2, and HCO3 bicarb, partial carbon dioxide and bicarb. So these are the three things which is deciding about your ABG. Okay, so acidosis and alkalosis, which decides whether your body is in acidosis or alkalosis or in a neutral state. So the normal pH you all know 7.35 to 7.45. PCO2 you all know 35 to 45. HCO3 you all know 22 to 26. I'll give you an easy way to remember it. Okay, so first set up a chart like this when they give you the value. So this is the chart: pH, PCO2, HCO3. So pH is on the top. Okay, the first thing you have to look at is pH. Okay, then second thing you have to keep is the um, PCO2. So PCO2 comes second. Look at the 2 in the CO2. So because it is having 2, just to remember, it comes second. Okay, lung is above. Then bicarb is the third thing, HCO3. So you put it at the third level. So remember, PCO2 is for lungs and bicarb is for kidney. Lung on the top, kidney on the bottom. 2, 3. So you have to arrange it in order: pH, PCO2, and bicarb. So that is the first thing you will do. Now you will mark this chart. Second thing is you have to mark the chart. Top line is 7.35, 7.45. Okay, so top one is 7.35 to 7.45. That is pH is 7.35 to 7.45. Middle PCO2 is 35 to 45. Okay. Okay. Okay, and the bicarb HCO3 is 22 to 26. You have to mark it like this. Okay, and label it. Now you have to label it acid and base. So 37.35 to 7.5. If it is less than 7.35, then it is acid. If it is more than 7.45, it is base. Second line, you will reverse it. Okay, it comes like the zigzag. Second line, 35 to 45. If it is less than 35, it is base. That is alkaline. If it is more than 45, it is acidic. Okay. Then bicarb, if it is less than 22, acidic. And if it is more than 26, base, alkaline. Okay. So you have to mark your chart like this. So you can make a zigzag like this. So A, B, B, B. You got it? Did you understand this? Everybody? Okay,
Yes, sir.
so let me just show you a chart. Okay, so pH, PCO2 is second, and HCO3 bicarb is third. Okay, so pH normal is
7.35 to
7.35 to
7.45.
7.45. PCO2 normal is
35 to
35 to
40.
45. Okay, then HCO3 normal is
22
22
to
22.
20
40,
to
26.
26.
26. Okay. Um, okay, so now you can mark like this. So here A, this is B.
Okay. Yeah, patient.
This is B. This is
A.
this is A,
A.
and this is B.
B.
Okay, and if your value is given, for example, let's say it's not going. Okay, so now let's do a thing. So pH is 7.22. Okay, this is a question. pH is 7.22. PCO2 is 46. Bicarb is 29. Okay, so that is your value. That is your question. Okay, pH is 7.22. PCO2 is 46. Bicarb is 29. So when you apply here, so pH 7.22, it is less than 7.35. So it is acidic.
Acidic.
Okay. Now coming to this thing, PCO2 is 46. Okay, so what is that? It's more than 45.
45.
Okay, so it
Yes.
is
Acidic.
Acidic.
Okay, bicarb is
More than
29.
normal.
More than.
So it's more than 26. So it is alkaline. So
Alkaline. Yeah.
alkaline. So now your answer is your ABG is respiratory acidosis because PCO2 and pH is matching. Okay,
Yeah.
so you have to find out which is matching with the pH. Okay,
Yeah.
when the pH is matching with the PCO2, then it is acidic.
Acidic.
If it was vice versa, if the pH was matching with the bicarb,
Bicarb.
then it was
Metabolic.
metabolic. Okay, metabolic acidosis. Okay, so it's like that. So this is the easiest way to understand, and I'll come to the compensatory mechanism later. Okay, everybody got it?
Yes.
Yeah.
Is any question, any doubt? Okay, now next is the compensatory mechanism. This area is a little easy for us. If you remember this pH, PCO2, HCO3 is easy. There are a lot of other methods to learn. There is tic-tac-toe method, which I used to teach my students using tic-tac-toe method. But when I saw this, I felt this is more easier than tic-tac-toe. So that is why I thought of teaching you guys this method. Okay, so there are different methods. Whichever is comfortable for you, you can learn that. Okay, now the next step is the most dangerous thing, or we all have trouble with, is to understand. Trouble with understanding is the compensatory mechanism. Okay, so there are 3 steps to know the compensatory mechanism. Okay, so before compensatory mechanism, yeah, so like before moving into compensatory mechanism, let's finish this. So pH is primary. Look here first. pH below 7.35 is acidosis. You know that. pH over 7.45 is base alkalosis. That is the first thing you will decide. Second one, match pH with the partner. That is what we did now. Let's say pH is under 7.35. So PCO2 is over 45 and HCO3 is normal. Okay, so for example, let's say like this. Okay, so for example, let's say as they told pH, say pH is less than 7.35. So let's keep pH as 7.22. Okay, and they say PCO2 is over 45. Let's keep PCO2 as 55. And then HCO3 is normal, that is
Normal.
HCO3 normal. So what is a normal HCO3? 22 to 26. So let's
26.
keep 24. Okay. So now you know that pH is 7.22, so it is acidic.
Respiratory
Yeah.
acidosis.
PCO2 is 55. It is more than 45, so it is acidic. Okay, and HCO3 is common.
Within normal.
It is normal. So only two pH is matching only with PCO2. Okay, so this is this. Let's do another sample here. If pH is 7.45. Okay, pH is 7. Okay, so 7.50. Okay, let's keep 7.55. And PCO2 is PCO2 is 45. Okay, and bicarb is bicarb is 29. Okay, now let's do this. pH 7.55 means it is more than 7.44, so it is alkaline.
Alkalosis.
Okay, PCO2 is 45. It means that it is
It's normal.
Normal.
Okay, HCO3 is 29.
It's
What does that mean?
alkalosis.
That's alkalosis.
Okay, alkalosis. So pH is alkalosis, and this pH alkalosis is matching with bicarb alkalosis. So the patient is having metabolic alkalosis. Okay, got it? So those are the two steps, and the third step is compensatory, deciding whether it is a compensatory or uncompensated, or fully compensated, partially compensated, or uncompensated. That is a thing which we are going to see now. So what do you understand by this compensatory mechanism? It means that your pH is abnormal. Your pH is abnormal. Now your body, that is your lungs and your kidney, is trying to compensate. Okay, so trying to bring it back to the normal range. So your lung is doing something to bring it back. Your kidney is doing something to bring it back. Okay, so a little tricky, little difficult to understand. So if you focus on it, you can easily understand. So compensation means finding common ground to make the pH with normal range. Fully compensated is equal to pH's normal range. Okay, so it means that the kidney and lungs are doing their part and has brought the pH to normal range. So it means that pH is a normal, but you know what? Your kidney, that is PCO2 and bicarb, is still abnormal. Okay, because they are compensating. That is why they are abnormal. So pH is normal, but your PCO2 and bicarb is abnormal because they are compensating, and they brought the PCO2 to brought the pH level to the normal level. Okay, so that is known as fully compensated. If you see a value pH is normal but other two is abnormal, then it means that your kidney and lungs have compensated for it. Okay, so now let's see about uncompensated. Okay, so uncompensated means your kidney and your lungs are not doing anything. Okay, they are not doing anything. So what happened? The pH is outside the normal range. Okay, so in this case, you can see pH is outside the normal range, but either PCO2 or bicarb will be abnormal, and one is abnormal and one is normal. Why? Any idea? Because it is either PCO2 or bicarb. Any one of this is making the pH abnormal, right? So when PCO2 is abnormal, what happened? the pH will become abnormal, or the bicarb is abnormal, pH also become abnormal. So any of this value, PCO2 or bicarb, is making the pH abnormal. That is why in case of uncompensated mechanism, what happens is you can see PCO2 abnormal, pH abnormal, and either PCO2 or bicarb will be abnormal. Any of one thing will be abnormal. You're getting it? Anybody, any confusion? So you can see pH is always abnormal, and either pH or PCO2 will be abnormal. Okay, only one will be abnormal. Okay, so if all the three, if another one is becoming abnormal, it means that it is trying to compensate. So when it is trying to compensate, the other one will also become abnormal. So when you see this next thing, the partially compensated, in this case, you can see it means that pH is outside normal and both the values are outside normal, because one value is causing the pH to be abnormal and another one is trying to compensate. That is why partially compensated. So the problem may be because of lungs. Okay, the problem may be because of the lungs. The patient is having acidosis. Okay, the patient is having acidosis maybe because of the lung. So what happened? To bring that acidosis to the normal range, your kidney is your kidney has started to compensate. So that is why you can see both all the pH, PCO2 and bicarb, all the three is abnormal. If you are finding it difficult to understand, this chart will help you to understand. It is fully compensated if the pH is normal. Okay, if you find a value pH is normal, then it means it is fully compensated. It is partially compensated if all the three values are normal. I told you one value is causing the pH to be abnormal and another value is trying to compensate. So that is why you have all the three values abnormal. In uncompensated, only PCO2 and in uncompensated, what happened? Or PCO2 or bicarb is normal and the pH is abnormal. So in uncompensated system, pH is always abnormal. Either PCO2 or HCO3, one is normal and one is abnormal, because one is causing the pH to be abnormal and the other one is normal, in the normal range, because it's doing nothing. It's not doing nothing to help the pH to come back to the normal range. So that is why it is known as uncompensated, because your body is not trying to compensate for it. Okay, so I don't know if you have understood it. I know that it's very difficult to understand. So let me just go back and I'll show you this chart for you to better understand things. Okay, so see here. If you look at this chart, you can see the pH is in normal range and PCO2 is more than 45. What does that mean? More than 45 means acidosis or alkalosis? Acidosis. Okay. More than 45, PCO2 is acidosis. And now you can see bicarb more than 26. It means that it is alkalosis. Now you know what happened here. The value of this pH was actually 7.4, 7.25. The value of this pH was 7.25. Imagine it was 7.25. This value was 7.25 because of this lungs. The lungs is not working properly. That is why the patient went into acidosis. 7.25 is acidosis. Now what happened? Your kidney recognized that, oh my God, my body's pH is having acidosis. So what I will do, I will increase the bicarb level. So when I increase the bicarb level, what happened? The blood goes into the alkaline state. Okay, so when the blood goes, when the bicarb is trying to bring the blood back into alkaline, what happens slowly? You can see this pH of the blood drop coming back to the normal range. That is why in fully compensated, you can see pH normal and other two values are abnormal. It means that it's not been treated. Still, the lung is having problem. The lung is still having the problem. Lung has caused the pH to be acidic. Now what? Your kidney recognized it and kidney increased its bicarb level. When the bicarb level increases, what happens? It will make the blood alkaline. So an acidic blood is what is your kidney HCO3 is making the acidic blood alkaline and bringing back it to the normal range. Did you get it? That is known as compensatory mechanism. You got it? Okay. So let me ask you another question. What is happening to the lungs here actually? What is happening to the lungs? For example, you don't breathe properly, right? You're not breathing properly. That is when all the carbon dioxide settle
Retaining.
inside. Okay, retain inside. And what happened? The value 45 goes the PCO2 value goes above
Increased.
45 increase. And what happened when the PCO2 value go above 45, the pH start dropping down and the blood's pH will come less than 7.35, leading to acidosis.
Leading to acidosis.
Okay, so that is why PCO2, and this is why PCO2 is causing acidosis. When you're not breathing properly, when a patient is not breathing properly, carbon dioxide accumulate inside. When carbon dioxide accumulate inside, the PCO2 level goes above. When the PCO2 level goes above, pH start dropping down, leading to acidosis. Okay, now the kidney recognized it. And what happened? Your kidney is increasing the bicarb level of your blood. Okay, when the bicarb level is increasing, what happened? Slowly
Alkaline.
Going back to
alkaline, the
normal.
pH goes back to normal.
Normal.
Okay, so that is why here in fully compensated mechanism, you can see pH normal, PCO2 and bicarb is abnormal. Okay, now let's see this uncompensated mechanism. Okay, so you can see pH is 7.35. Again, same thing has happened here. The patient is not breathing properly. Because the patient is not breathing properly, the PCO2 level is going above 45, leading the pH to drop down. Okay, and now you can see bicarb is staying in normal. It means that the kidney is not doing anything. Kidney is not friendly. Kidney doesn't want to help. That is why in this case your bicarb is staying in the normal range. Okay, so if you see a value pH abnormal, either PCO2 or bicarb is normal and one is abnormal. In that case, it means that your body is not compensating. Okay, if the problem was with bicarb, okay, if the problem was with bicarb, then your lungs would have compensated for it. But in this case, both are not helping each other. So that is why it is known as uncompensated. You got it? Okay, so say this example, PCO2, a patient is not breathing properly. Because he's not breathing properly, carbon dioxide gets collected inside the blood. So what happened? PCO2 level goes above 45. When the PCO2 goes above 45, the pH start dropping down, making the blood acidic. The blood will become acidic. So now your bicarb should have helped. It should have compensated. But here in this case, your bicarb has not started helping. Your bicarb stays in the normal range. And that is why it is known as uncompensated. Okay, bicarb is not helping each other. Let's put this into another scenario because they may ask you very differently in your exam. For example, let's keep like this. The problem is with bicarb. Okay, so the bicarb level is 16. Okay, bicarb level is 16. Okay, so just for an example, bicarb level is 16. So it means that the pH is less than 7.35 because of because the kidney is not working properly. Kidney is excreting too much of bicarb and body is not having bicarb. So that is the reason why the bicarb level has dropped down. When the bicarb level is dropping down, you can see the pH will also drop down to acidic. When the bicarb is dropping down, it means that your blood is making, when there is less bicarb, the blood will become acidic. Okay, now now your lungs will recognize it. Lungs will understand that the patient is having, what is that? The patient is having acidosis because of the kidney not working properly, because of because of reduced bicarb level, patient is having acidosis. So now what your lung will do is lung will stop working. Okay, so it will try to it will try to reduce the what is that? It will try to, yeah, it will try to reduce the CO2 in the blood. It will, so your lung will start to remove the carbon dioxide by hyperventilating. Okay, when the patient start hyperventilating, what happened? All the PCO2 will be removed. So what happened when all the PCO2 will be removed? The PCO2 level will go
Alkaline.
down. Okay, it will go to alkaline and it will start moving the pH to normal range. Okay, so that is known as so now in this case, if the PCO2, if the lung is not hyperventilating, it means that the lung is not helping. Okay, so if you see the PCO2 level is normal, it means that the lung is not helping. So it is known as uncompensated.
Uncompensated.
Okay, now let's see this example. Compensated. Okay, in compensated mechanism, you can see all are abnormal. Sorry, I mean a partially compensated mechanism, you can see all are abnormal. It means that the one of the organ has started working. One of the organ has started working, but they have not reached a conclusion. I'll see you to remember about this partially compensated mechanism. I'll tell you about something. A husband and wife is having trouble. Okay, a husband and wife is having trouble. Now, what is that? A marital counseling is going on. Okay, it's going on. The marital counseling is going on, but they have not reached a decision yet, whether divorce or continue forward. So that is the case here. Here, PCO2 and SCO3 is still in the abnormal stage. They are trying to work out. Okay, one of the things is trying to work out, but they have not reached a decision yet. They have not reached the thing. So that is why you can see all the values are abnormal. So let's see the example here. Okay, so just give me a second, 1 minute. Okay, so let's see the example here. Here the patient is acidic because of this PCO2, because the patient's lung is not working properly. So what happened? All the carbon dioxide is getting collected in the blood, and because carbon dioxide get collected, the pH drops down, lead to acidosis. Okay, now your bicarb, your kidney recognized it and it has increased the bicarb level in the blood, but still the pH is in the abnormal range. It have not reached the normal range. It means that it has started compensation, but it hasn't reached the point. Okay, it's still compensating. Okay, so that is known as partially compensated. You got it, everyone? Now let's practice a lot of questions, only then you will get it. Let's do one question here. Okay, Meena? Meena, can you answer this question? Hello? Meena? Okay, Manju?
Yes.
Yeah, Meena, can you answer this question?
Yeah.
The full thing.
pH is 7.25, PCO2 is 55, and PCO3 is 25. So pH is 1.25, so it is acidic, and PCO2 is 55, that is also acidic, and PHCO3 is 25, so it's normal. So it is respiratory acidosis.
Okay, let's put the chart like this. pH is 7.35 to 7.45.
45.
Okay, next is PCO2. PCO2 is 35 to
45.
45. Next is HCO3 is 22 to 26.
26.
Okay, so now I'm sorry, I don't know. Just because Felix advised me, I bought a MacBook this time. I don't know how to use the MacBook. That's my problem. Okay, so let's keep like this. So, okay, so this is acidosis.
This is acidosis.
Alkalosis.
This is alkalosis. This is
alkalosis.
This is acidosis.
Again,
Acidosis.
acidosis.
Alkalosis.
Alkalosis. Okay. Now put it here. pH 7.25. Yeah.
It's acidosis.
So pH is acidosis. Okay. So pH is
Acidosis.
acidosis. Okay. Now next one, PCO2 is
PCO2 is acidosis.
okay. PCO2 is 55. So PCO2 is
Acidosis.
acidosis. Okay. Now bicarb.
Bicarb is normal.
HCO3 is normal. Okay, now what is your answer?
It's
Respiratory.
respiratory acidosis.
Okay, it's respiratory acidosis. Now you have to find out what type of compensatory mechanism is this?
It is pH is not normal.
So what did I tell you?
It is uncompensated.
Very good. It's uncompensated
Uncompensated. Yeah.
because the bicarb, your kidney is not helping. Okay, so that is why your kidney is staying in the normal range. Got it?
Yes. Yes.
Okay,
Father.
your lung is having a problem. That is why patient is having acidosis. Your kidney should have compensated for it in this case, but your kidney is not compensating. It's staying in the normal range. That is why it is known as uncompensated respiratory
Acidosis.
Okay, let's see another question here. Manju?
Yeah. Yes, sir.
don't you go ahead this question?
Okay. pH 7.57. It's alkalosis. PaCO2 25. It's alkalosis. Bicarb 22 within normal.
Was that the same question which we saw?
No, it's a different, sir.
Okay.
22, 26, yeah.
Okay, so now tell me, so what happened to the pH? pH is
7.7457. It's alkalosis.
okay. pH of PCO2.
PaCO2 25 is less than normal. It's acidosis. No, alkalosis. Acidosis.
PCO2 acidosis.
Oh, it's alkalosis.
Alkalosis. PCO2 is 25 here. Okay, fine. Okay, so PCO2 25 alkalosis.
Alkalosis.
Okay, yeah, then bicarb.
Within normal. It's a 22. It's a normal.
So it's normal. So
Yeah.
what is the problem here? Respiratory.
Respiratory alkalosis.
Respiratory alkalosis. Compensatory mechanism.
Uncompensated respiratory alkalosis.
Uncompensated respiratory
Alkalosis.
Okay, let's see another question. Kamalpreet. Kamal Moga.
Yes. Yes.
Yes, go ahead. Kamal. Just give me a second, 1 minute. Yeah, go ahead.
pH is
7.21. So, oh my God. This is A, B, B, A, B. So pH is 7.21. So it's alkalosis or acidosis, less than 3.5.
acidosis.
Okay, less than 3.5 is acidosis. Very good. PCO2 39.
It's a normal range. Normal.
Range. HCO3.
It is under 22. So it is acidosis.
It is HCO3. Okay,
Yeah.
it's under 22. It's acidosis. Very good.
And the mechanism is compensatory, I guess, because in this case the bicarbonates are lower, so kidneys are not working in this thing.
So it's compensated or uncompensated?
It's compensate.
Oh, compensated. If it is compensated, pH would have been normal, right?
Oh,
Yeah, it's uncompensatory.
Uncompensated,
Metabolic
metabolic
acidosis.
acidosis.
Yes.
Okay.
Acidosis.
Okay, let's see 3 more questions and then we'll finish this off. Okay, and also I'll send you some questions for you to practice with answers so that so this is a TikTok method which I used to teach, but just forget about it. We are not going to do that. Okay, Kamal Chahal. Kamal?
Yes, Father.
Yeah, good.
So here in this case, pH is,
Sorry. Yeah.
so pH is less than 35, so it's acidosis.
Hmm.
CO2 is 32, so it's alkalosis.
Okay.
And soda bicarb is acidosis.
Mhm.
Yes.
You were very fast. I didn't follow it. Okay, so pH was acidosis, right?
Acidosis, yes.
Yeah. PCO2.
Alkalosis, because PCO2 is less than 35.
Okay, very good. PCO2 is alkalosis.
And soda bicarb is normal
Sorry,
range.
1 minute.
Sorry.
PCO2. Okay, fine, good. Yeah, bicarb is.
Bicarb is less than 22, so it's acidosis.
Okay. Acidosis. Yeah. So now tell me what is the thing here?
So in this case, all are in abnormal range.
Yes. So if all are abnormal, it means that. So first, what is the problem here? Respiratory acidosis, alkalosis, metabolic acidosis, or metabolic? What is the problem here? pH is acidosis.
Yes.
So you have, what did I tell you? You have to match
Match.
pH with respiratory or metabolic, which is matching. Respiratory or metabolic is matching with pH.
Yes.
pH is decreasing and soda bicarb is decreasing.
So
It's
pH is acidosis,
yes.
and so bicarb is acidosis. So the
metabolic
patient-
acidosis.
Yeah, metabolic acidosis is a problem.
Yes.
Okay. So because of the kidney, the patient is having acidosis. Now your lung is trying to compensate.
So
Okay,
it's
but-
partially compensated.
Very good.
Metabolic acidosis.
Partially compensated metabolic acidosis, because here in this case, your lung is trying to compensate, but it hasn't compensated yet because the pH is still in the abnormal range. Okay, it means, so if all the three values are not matching, sorry, I mean, if all the three values are abnormal, then it's always partially compensated. Got it?
Yes.
Okay, next, Jomia. Jomia. Hello, Jomia. Okay. Elsa. Elsa, not there. Danya. Danya.
Yes, Father.
Yeah. Go ahead, Danya. This question.
pH is 7.44. It's normal.
Okay, pH is normal.
PaCO2 less, so it's alkalosis.
PCO2 is less, so it is alkalosis. Very good.
HCO3 is also less, so it's also alkalosis.
HCO3 less sound by alkalosis. Are you sure? If HCO3 is less, it's alkalosis. What did I tell you? I told you to mark it. A, B, B, A, A, B. So it is acidosis, right?
Acidosis. Okay.
Okay, so when HCO3, it's acidosis. So that is why I told you to mark it and learn. Okay, it's very difficult for me to mark it. That is why I didn't mark it here. So let me just put it again. Otherwise, I don't want anybody to leave without knowing it. Okay, so here I'm struggling with this laptop. I'm sorry. Okay, so here I told you always mark it A, B, B, A, B. Okay, so you marked it like this. So if it is less than 35, pH less than 35, it is acidosis. PCO2, you told 30. 30 is less than 35. So it is base, right? So it is alkalosis. Got it?
Yes.
And HCO3, 22 to 26, 21 is less than 22. So it is acidosis. Got it?
Yes, Bobby.
Now, what is your answer?
Respiratory
Hmm.
acidosis.
Okay, respiratory acidosis. How did you decide that it is an acidosis? Well, how did you say it is respiratory acidosis? You're already your respiratory. This is alkalosis.
Yes, Bobby. Yeah.
Why did you say it's respiratory acidosis?
Oh, metabolic.
Hmm? So, okay, metabolic. First thing, you know that your pH is normal, right? In that case, I know that it is very difficult. You are now confused how to decide because pH is something which decides whether it is acidosis or alkalosis, right? Now, in this case, you can see pH 7.44. It is in the borderline of alkalosis, right?
Yes.
Borderline of alkalosis. So keep it as alkalosis, though it is normal. When if you want to determine it as a this thing, what it determine the compensatory mechanism, you have to keep it. Okay, so let's keep it alkalosis. Okay, because it is in the border of alkalosis state. It's the border of alkalosis state. Okay, now tell me what is the problem here?
Respiratory alkalosis.
How, okay, respiratory alkalosis because pH is alkalosis. The pH is normal, but you know, it is in the borderline of alkalosis. It is in the borderline of alkalosis. So let's understand it as alkalosis. So the problem here is respiratory alkalosis, and your bicarb has compensated and it has brought from alkalosis range into the normal range. Okay, so your bicarb has compensated and brought this into the normal range. So now tell me what is the compensatory mechanism?
The pH is normal, so it's compensated.
It is compensated, fully compensated. So what is your answer? Respiratory,
Respiratory alkalosis.
compensated, fully compensated respiratory alkalosis. Got everyone understood this problem? Okay,
Yes, sir.
so when you see the pH in normal range, okay, think which side it is and the which borderline it is. It is if it is on the base borderline, then it is alkalosis. If it is on the acid borderline, then it is acidosis.
Acidosis.
Okay, so understood that. Let's
Yeah.
do one more question and then we'll finish off. Adira?
Yes, Father.
Yeah, go ahead, Adira.
pH is
Just give me a second.
Yeah.
Yeah. So what is pH?
pH is 7.1. So it is acidosis.
Just give me a second. Yeah, go ahead.
pH is 7.1.
Hmm.
Is acidosis.
Okay.
PaCO2 is 40.
Hmm.
It's in the normal range. HCO3 is 18. So it is acidic.
So what is the problem here?
It is sorry. It's metabolic acidosis,
Metabolic acidosis, very good.
and it's uncompensated metabolic acidosis.
It is uncompensated metabolic acidosis. Okay, very good. Hope you all have understood acid base. I mean, calculating and interpreting an ABG. Okay, any doubt, any confusion? Was it easy or was it difficult?
It was easy for when you.
It
Okay.
was easy.
It was easy. Okay, good. So I was using other methods. So this time I just wanted to try this method. Okay. So hope that helped. Tomorrow we'll see about metabolic acidosis, metabolic alkalosis, respiratory acidosis, and respiratory alkalosis, signs and symptoms, and what are the treatment of all those things. And then we will be jumping into fluid and electrolyte balance. There are few more fundamental nursing things, which I feel like it is just a lecture. So I don't want to give you any lectures because it's very boring. I don't like to give lectures. So what I do is I have prepared the notes for those things and I'm sending it to you today. Felix will be posting it today, tomorrow, like that. So what you do is try to read those notes. It's just simple lectures. I don't have any questions to ask or something to discuss in it. It's a dry subject. So just read it. Whatever is very important, that is what I'm teaching in class. So please don't forget to read those notes. Please read those notes because I'm just focusing on in class. I want to discuss something which you should not forget in your exam. Okay, so thank you everyone. See you all.